Okay, let's have a look at highest common factor and lowest common multiple, often shortened to HCF and LCM. And before we can answer questions that are based on this idea, we need to know how to find the HCF and LCM. So that's what I'm going to do in this video. The first thing we need to do, if we're posed with a question like this one, for example, find the HCF and LCM of 72 and 120, is to find the prime factors of both numbers. So just to remind ourselves, a factor is a number that fits inside another number and by multiplication leaves no remainder. And a prime factor is any factor that is also a prime number. So in order to obtain prime factors, we would look at this kind of situation here, and I've split 72, dividing it by the first numbers that come into my head really, but keep it simple, 2s, 3s and 5s, sometimes a 7 and an 11, but start with the simplest things first and just whittle it down by division until all you have are prime factors. So as you can see here, 72 has divided by 3 again, and then the final number there, 8, is divided by 2 3 times. And we would ordinarily write that in this format here, which is known as the product of prime factors. So as you can see, we've got 3 squared, 2 cubed, and those two in turn are multiplied together. Likewise then with the 120, I've split that out into 5, 3, 2, 2 and 2, and again if we were to write it as a product of its prime factors, it would read 5 times 3 times 2 cubed. Now when we're trying to find the highest common factor, what we do is we look for matching pairs. And so in this case, sorry, just take that back up a little bit. If we look at those orange lines, we can see that we've got a matching 3, a matching 2 and another matching 2, and the third one also. So the matching pairs gives us a matching 3 and 3 sets of matching 2s, and when you multiply those all together you get 24. So 24 is the highest common factor of 72 and 120. Now to find the lowest common multiple, we look for the highest power of each prime factor. So regardless of which number the prime factors come from, we look for the highest power of each. So going back to the diagram, we have 5, and it occurs just as a single 5. It doesn't occur in this one, so the highest power of 5 overall is just 5. Now we have a 3 here and a 3 squared here. So the highest power of 3 that occurs there is 3 squared. And then finally we have in both cases 2 cubed. And so the highest power of each prime factor multiplied out gives us 5 times 3 squared times 2 cubed, which is 360. Now that's one of several methods that you can use to find the prime factors, and I'm just going to quickly show you an alternative here written in blue using a Venn diagram. Okay, so we have the universal set in the rectangle, we have the two numbers represented by a circle each, and once we've separated out the prime factors as in the previous method, we place any matching pairs in the centre in the overlap, and anything else goes in its appropriate circle. And then the multiplication of the numbers in the overlap gives us the highest common factor, and the multiplication of all the numbers gives us the lowest common multiple. Now, as with a lot of things in maths, various methods suit various people. Some are easier to remember than others, so choose a method that you like, that gives you the right answer, and stick with it.